In the last video, we created a very simple VR program consisting of a rotating cube. In this video, we will examine this program in detail. We have a sample scene currently containing 3 game objects: a light, a player, and a cube. A game object refers to a virtual item in our 3D world. Our 3 game objects are at the top level of our sample scene. That is to say, the scene is their parent. Let's open up the player object. The player has a number of children, including, under SteamVR objects, the left hand, the right hand, and the VR camera. Each of these is also an instance of a game object. Each game object has a type. For example, the left and right hands are 2 instances of the same type, one of which is configured as the left hand and one of which is configured as the right hand. Look again at the cube. This has 6 components. All game objects have a transform component. It defines the position and rotation of the game object relative to its parent. There is a mesh, which is basically the shape of the object, a renderer, which is how to draw the object, a collider, which is used to detect collisions with other objects, and is often a simpler version of the mesh, the rotate cube script, which we wrote in the last video. We can see there is a start function for initialization, which we are not using, and an update function called everyFrame, which we are using to rotate the cube. And the material, which is used by the renderer and is painted onto the surfaces of the cube. This box here represents an instance of a game object. For example, our rotating cube. It is defined by an asset type. For the cube, this is the cube type. There only needs to be one cube type, but there may be many cubes. The asset type itself consists of 1 or more components, such as the transform, the collider, the mesh, etc. Each of these components requires instance data for our instance. So our rotating cube needs the position and rotation to be defined. So in summary, a game object instance, our rotating cube, has its personality defined by its instance data, which fills in the various fields of the components which make up the asset type. When we run the program, we can see the Y rotation increasing by 90 degrees a second. Note the angles are normalized in the range plus or minus 180 degrees. Within the script, GameObject refers to the game object of which this script is a component, our rotating cube. Although we have called this script rotateCube, it would actually rotate any game object to which it was added as a component. As I mentioned earlier, all game objects have a transform component. It defines the position and rotation of the game object relative to its parent. We created the cube under Game Object, 3D Object, Cube, but you can see there are several types of game object, and the simplest of this is empty. Of course, the empty game object is not completely empty, because all game objects have at least a transform component. Let's create a capsule. And let's attach our rotate cube script to it. Now, if we run, we can see the capsule rotates, but due to its symmetry, the rotation is not obvious. If we rotate it 90 degrees about the x-axis, that doesn't help. Okay, let's remove the script from the capsule, make the capsule a child of the empty object, and apply the script to the empty object. Perhaps if we swap positions, it might look better. Now you can see the benefit of the empty game object. Let's put the cube in there as well. Now let's look at the player in more detail. First of all, the player transform. This defaults to position and rotation of all zeros, and they remain unchanged as you walk around your room VR area, so it is not the current location of the player. Really, this would be better named as play area, the transform being the location in the VR world of the center of the floor of your room VR area. Changing the player transform changes the location of your real room VR area within the virtual VR world, as happens, for example, when using the teleport feature available in some games. If I highlight the player, I can move this around and everything to do with the player moves. If I play the game, you can see as I move the headset around, the player transform doesn't change. And there, if you look just to the left of the camera icon, there are the hand icons. If I set the player transform back to 0, they all move. Everything associated with the player moves because I have just moved your room VR play area in the virtual world. Next, the body collider. Well, the name tells you what it is. You'll also notice that the collider and the script associated with it are both currently disabled. I want to use the body collider to prevent my room scale VR player walking or looking through objects and walls in the VR world. Now, I did get there in the end, but it took a lot of fiddling. So that will be the subject of video number 4 of this series. Okay, next up, left and right hands. They follow the position and orientation of the handheld controllers. So as I move my controller around, you can see the shape. Also, it can detect movement of the fingers and even the thumb as I rub it on the large button on my controller. We have already seen how the hand models react to collisions with objects in the VR world. This is managed via a set of colliders which are created at runtime. Now if we watch down here, you see the hand colliders only came into existence when I started running. And as you can see, there's an awful lot of them on the hand. Now I assume they come into existence at runtime because the exact form is dependent upon the type of controller in use. Of course, the VR hardware is abstracted from the program. The VR camera. The one and only camera in your virtual world. Actually, of course, it's 2 cameras, one for each eye. The position and orientation of this VR camera matches your headset. This is your window into the VR world. Follow head contains the one and only audio listener in your virtual world. Actually a pair of listeners, one for each ear. This is the sound equivalent of the VR camera. And a head collider. Once again, the name tells you what it is. I'll come back to this in the next video. So, to summarise, the contents of the virtual world is made up of a number of game object instances. Each game object instance is of a defined type, consisting of one or more components. The game object instance personality is defined by the instance data for each of the components making up the type. All game objects have a parent, which may be the scene, such as for the directional light, or another game object, such as the player or the SteamVR objects for the body collider. Hence, it is possible to construct quite complex virtual objects by combining some game objects as children of others, and the player is a classic example of this. Assets are items which are available to be included in your scene, either as game objects or components. For example, the player, or perhaps a script. Assets can be downloaded from the Unity Asset Store. They can also be downloaded from third-party sources, or you can create your own 3D models, scripts, etc. Right, that's it for now. In the next video, I'll show you how I dealt with the issue of stopping the real-world player from walking through virtual world walls and objects. Thank you.